For part 2 in our inverse function videos, we are going to be looking at two separate functions and trying to decide are they inverses of each other or not. If you have watched part 1, you already know how to go from having a function to creating its inverse. So really, checking if two functions are inverses of each other is basically the same idea. Take one of the functions, swap the variables x and y's places, and then solve for y. But in case you need a little more refresher, we'll do a couple examples here and see if we can decide are two functions inverses or not. So let's get started. Here we have the function f of x equaling 4x plus 4 and the function g of x equaling negative 4x minus 4. Our goal is to decide, is this function the inverse of this function, or vice versa, is g of x the inverse of f of x? Because if they're inverses of each other, it doesn't matter which one we start with. I'm going to start with f of x, and I'm going to try and see, can I change it into this function by just swapping x and y. As you notice, though, we don't have a y, and that's because we take the function notation here, f of x, and we'll rewrite the function as y equals 4x plus 4. Alright, so our function f of x is here, and just like we saw in the part 1 video, we're going to trade places with the y and the x. So it's going to become x equals 4y plus 4. Now the goal is to solve for y. So we're going to take away the positive 4 by subtraction. That's going to give us x minus 4 equals 4y. And at this point we might be saying, hey, I've got a minus 4 right here. The g of x function has a minus 4 right here too. I'm possibly on the right track. But don't jump to conclusions. We need to finish the entire thing. Now I need to get y all by itself, so I'm going to have to divide by 4. So if I divide by 4, I have to divide everything over here by 4. And we're going to end up with y equals x minus 4 all over 4. And then we can rewrite this y in function notation, and since we already used f, we can use the g. So g of x equals x minus 4 over 4. And now we have to compare. Is this the exact same as this? And hopefully by looking at it you realize no, they are not the same. So therefore these are not inverses. When we trade our x and y and solve for y, this has to match this identically for them to be inverses. And since they don't match, they are not inverses. Let's try another. Here I have the function f of x equaling 1/3 times x, and the function g of x equaling 3x. Just like before, we want to take one of our two functions, swap the variables x and y, and then solve for y. I'll take our function f of x and rewrite it as y equals 1/3 x. Swap my variables, so x equals 1/3 y. And now I have to solve for y. And remember, if y is next to a fraction, and the fraction is 1 over something, to get rid of that fraction, all we have to do is multiply by the denominator. If this wasn't a 1, if this was something else, we couldn't do this, but if it is a 1, we can just multiply by the denominator. So if I multiply both sides by 3, those cancel out, and what do I have left? I have y equals 3x. And then if I put it to function notation, I'd have g of x equals 3x. Does this match this? And hopefully you say to yourself, yes, it most certainly does match. Therefore, these are inverses. So yes, f of x and g of x are inverses. So that's all we have to it. When we're comparing two functions, trying to find out if they are the inverses of each other, we use the same method as part 1. Rewrite one of the functions so that it's y equals, then swap your x and y, solve for y. And if the functions match in the end, they must be inverses. Hopefully you found this video helpful. Good luck checking if two functions are inverses or not.